All right, let's talk about machine learning. We're going to cut through all the hype and demystify what it's really all about. And our whole journey starts in a pretty surprising place, a local bakery. Let's dive in. Okay, so picture this. You're at your favorite bakery. You go there all the time. You walk up and order 10 muffins. Now, based on all your past visits, can you guess how long that's going to take? This isn't just a random guess, you know. It's exactly the kind of real-world problem that machine learning is built to solve. So to make a good prediction, we need data. And here it is, a little logbook of our past orders. We've got the number of muffins we bought and exactly how long it took to get them. I mean, you can already see the pattern starting to form, right? More muffins, more time. Our eyes can spot that trend, but a machine can make it precise.
And that's really the main goal here. Out of all the infinite lines you could possibly draw through these little dots, machine learning helps us find the one line that gets the closest to all of them. We call this the best fit line. And this line is our model. It's a simple, elegant summary of the relationship between muffins and minutes. And this whole technique, it's called linear regression.
So after the computer crunches all the numbers, it gives us this beautifully simple formula. This equation right here is just the math version of that best fit line we just talked about. You can think of it like a little prediction machine. You just plug in the number of muffins you want, and boom, it spits out a really solid estimate of how long you're going to have to wait.
Now, this is where it gets really cool, because these numbers actually mean something in the real world. That 2.60, we call that the intercept. It's like the base prep time. You know, the time it takes just to get the box and tongs ready, even before the first muffin goes in. And the 1.97, that's the slope. For every single extra muffin you add to your order, it adds just under 2 more minutes to your wait. It's a simple but really powerful insight.
Okay, let's just pause on that for a second. The computer didn't just plot a line on a graph. It looked at our past experience, our data, and it learned the relationship between two things. It figured out a general rule from a bunch of specific examples. And that right there is the absolute heart of what machine learning is.
And you know, this isn't some brand new idea. Way back in 1959, an AI pioneer named Arthur Samuel defined it perfectly. It's not about telling a computer exactly what to do in every single situation. Nope. It's about giving it the ability to learn for itself, straight from the data.
Now, this technique we just used with our muffins, it has a name. It's called supervised learning. And it's supervised because our data was labeled. For every input, the number of muffins, we also had the correct output, the right answer, which was the time it took. It's kind of like we gave the computer a practice test that came with a full answer key.
And this shows us that what we did is just one of the main flavors of machine learning. On the other side of the coin, you've got unsupervised learning. That's more like giving the computer a giant, messy box of Legos with 0 instructions and just saying, hey, see if you can find any interesting groups in here. The machine discovers hidden patterns all on its own. It's how companies can figure out different customer segments without even knowing what those groups are ahead of time.
But here's the thing. Getting these incredible predictions, it's not magic. For a model like our muffin predictor to actually work and be reliable, we can't just throw any old data at it. The problem itself has to follow some basic rules of the road.
So for a technique like this to actually work, a few things really have to be true. First off, the relationship you're studying should actually look like a line. Makes sense, right? Second, the model's mistakes should be pretty consistent. It shouldn't be amazing at predicting small orders and then totally fall apart on large ones. And finally, you don't want to feed it the same information twice, like using both the total square footage of a house and its number of bedrooms to try and predict its price. That just confuses things.
Okay, so we can predict how long it takes to get muffins. That's kind of neat. But why does this simple idea of drawing a line matter so much? Well, because this exact same logic, when you scale it way up, is used to solve some of the world's biggest and most complex challenges.
I mean it. This same fundamental concept, learning a relationship from data to make a prediction, it's working behind the scenes literally everywhere. It's in healthcare, helping to predict diseases from medical scans. It's all over finance, calculating our credit scores and spotting fraudulent transactions. And yeah, it's the engine behind those recommendation systems on Amazon and Netflix that always seem to know exactly what you want to watch or buy next.
So if there's one thing to take away from all this, it's this. Even the most complicated, mind-blowing AI that you hear about today is often built on this very simple foundation. The simple act of fitting a line to a bunch of data points isn't just a boring math problem. It's truly a cornerstone of modern artificial intelligence. And that leaves us with a final, kind of wild thought.
If a machine can accomplish all of this just by learning how to draw one simple line, what happens when it learns to draw 1,000,000 of them? Or 1,000,000,000? What new worlds open up when machines can find patterns that are far too complex for our human minds to even begin to see?